means how we will get the product of coefficient. Some we will able to get based on the Pascal triangle, directly we will get in the form of 2 to the power n, but what will be the pattern of product of the coefficient? Then we can write here NCR, product r equal to 0 to n, this, then just we have to expand and we will make the product. Then directly you can say if you want to find any particular row, then we will not get much here like very, so you can say very sophisticated formula or any shortcut. But just to suppose if you are taking the ratio of two consecutive product Sn plus 1 divided by Sn, then you will get this pattern n plus 1 to the power n divided by n factorial. Or if you are just combining three different sum Sn plus 1, n minus 1 and Sn, and you are just putting in the same ratio way, then you are getting this pattern n plus 1 divided by n to the power n. In these two pattern you can say it will be useful. Now we'll come to the few LTI, just a representation of binomial expansion in different way, like x plus y to the power n. We know already, these also we know, these are the coefficient of the expansion. This is your binomial theorem. We already gone through each and everything, like just if you will put x equal to 1, then it will give you the sum of all the coefficient. Now this is quite interesting. We can just go through, like if any of the square, if you are dividing in the ratio of a ratio b, means side, if at side you are dividing in the ratio of a ratio b, then we can say this bigger square, whatever is given, this area will equal to a plus b whole square. That we know. Side square will be equal to the area of a square. Now a plus b whole square, we know it will be equal to a square plus 2ab plus b square. Now how geometrically we will able to prove a plus b whole square equal to a square plus 2ab plus b square? Just you can look. This is your a square and this portion of your geometrical figure, it is a square. This is your AB, this is your AB. This combinedly, this will become your 2AB. And this is your B square, this will become your B square. If you are adding all these figures geometrically, then it will give you a plus b, just a plus b. This will become your side a plus b, or a plus b this side also a plus b whole square. That will give you a square plus 2ab plus b square. This understanding of just cutting the figure and adding the figure, that will be much helpful to understand the geometrical representation of algebra, or you can say geometrical representation of numbers. Then here just we'll try to look, like if we are going for the next number a plus b to the power q, then how to represent. Like aq, this will give you 1q, like in center it will be there. Next it will be 3a square b, next it will be 3ab square, and next bq. Then bq will be one of the, this will become this corner q, this will become bq, this will become aq, and remaining this and this, it will become a square b, and this, and one side will be, that is hidden, that will become ab square. Then similarly here, if 4 number of terms are there, I think not much important, you already understood. Now this you just keep in mind, no need to worry if it is given any of the term in in negative way, like a minus b plus c minus d, then no need to worry how to do it. Just in place of plus you just put minus, nothing else. Remaining theorem will be same. Or this is your multinomial theorem, x1 plus x2 up to n to the power n, then factorial n will divide by alpha 1 factorial, alpha 2 factorial, where alpha 1 plus alpha 2 should be always equal to n. If you are adding the power all these, it should come to 1. And that is only different representation of multinomial theorem, or you can say more than 2 if it is there, then we can say it is a trinomial. Next, more than trinomial, in general way we can say it is a multinomial theorem. Then binomial theorem also, it is a multinomial theorem. Condition is number of terms should be equal to 2. Then this is good representation of geometrical a plus b to the power q, like this is one of the q, first q, this will come here. Second, this is your side, you can say a square b, one more will be there, back side hidden, this will become your a square b, and this is your, this lengthwise, this will become 3ab square, and this is small hidden cube here, that will become bq. A plus b square, a plus b whole square, we already understood, this is 2D figure. But a plus b to the power q, we know it will be a cuboid, then we can say it is a not 2D figure, it is a 3D figure. And a plus b to the power 1, it will become a straight line. Just to try to understand geometrically, this is your a plus b, this is geometrically what is a straight line. It is a line. This is your 2D plane. This is your 3D. This is your not 4D. 4D will not there. Only up to 3D. ऐसा नहीं बढ़ाते जाना 4D, 5D. No. We know only 3 dimension. Fourth dimension is there, that is time, but still mathematician, or you can say in physics, we are not able to use very frequently the dimension of time. But x, y, z, that is visible coordinate system. If anybody, if we want to locate in space, a spatial orientation, then we will use the x, y, z dimension. But apart from these 3 dimensions, fourth dimension is that is time. Time is the fourth dimension that only you will able to realize and you will able to calculate if you are moving with a certain speed or your movement is with respect to the speed of light.